Hi everyone, welcome back. This is part 2 of our lab safety videos in physics. This is Miss Granucci once again. In this video, what I'm going to do is talk about some of the labs that we're going to do and some of the lab precautions. Like I said before, we're not using chemicals, so the precautions are different. So I'd like to go over what you might expect in physics labs. So one of the first things that you'll experience, actually about 80% of our labs, is all going to be the study of motion of some sort, and forces, and energy, and momentum, which are all terms you'll come to learn. What means that we're going to do a lot of moving things. So we're going to have ramps and motion detectors, moving cars, rolling balls, and yes, flying pigs. There will be flying pigs in the classroom. Colliding cars, so lots of motion. So as anything with motion, be aware of your surroundings as always, but particularly, be aware of moving objects. Of course, you can trip on things if they're on the floor or if you have excess wires. Falling objects, we will be dropping objects at some point, so just know that falling objects may cause injury or bruising if they're, of course, they fall on you. Ideally, you'll be away from the situation, and that you won't have any objects actually falling on you, but again, when you drop an object, please be sure the floor is clear. Make sure that other things are clear from that location, and that you're aware of your lab mates as well. So one time I dropped a physics mass, which are pretty heavy, on my foot by accident, of course. I didn't do that on purpose, but it was really heavy, and I feel like it didn't break my foot, but I'm pretty sure if I had to question it, I would have questioned it, So, in other words, these things could be dangerous. Be very careful with them. Wear sneakers on those days, and I'll tell you when to bring in sneakers. They're not needed for every day. But as always, falling objects can cause injury. We're going to be colliding objects. Keep your fingers and hands and any other body parts away from those objects that are colliding. You don't want to pinch your finger or just be in the way during that time. We're going to be colliding carts in an impact lab, so again, just be aware of the situation and the potential hazards of that. So the biggest thing, the big take-home is be aware. Be aware of your surroundings, others, equipment, etc. And let me know if there's anything unusual or anything unexpected. So maybe that when you crash your cart, the cart falls apart for whatever reason. So please just let me know if that happens, or if the ramp doesn't work, or if anything turns up in lab, broken wires, etc. So I'm aware of the situation. But for most things, motion is going to be what we're going to be studying, so just be aware of moving objects. Projectiles, specifically, are things that go in the air, that you literally launch in the air. This could include what you'll see over here, which is a ball falling off the table, like that. In other cases, you'll be physically launching things in the air, like with a nerf gun. So with all moving objects, tripping hazards, excessive wires, and falling objects are all issues you have to be aware of. But when we do something like projectiles, especially with the nerf guns, you must wear protection. We're going to use goggles that are a little different than chemistry. They're called impact goggles, and they are meant to take the ideas to protect your eyes from projectiles, literally from things that go into your eye. So they're similar to the goggles you might wear if you're working on, if you're working on construction, you're cutting wood. You wear the same type of goggles. These are rated for 70 miles per hour, so they're meant to take any impact to your eyes. I do understand that Nerf guns are literally toys that you can buy, which you shoot around the house with your brother or sister. But we're not at our house, I'm responsible for you and the school is, etc. And I do ask you to wear goggles. Failure to do so will be a removal from the lab. So, and there's a picture down here. I know my face is kind of covering it here. But you can see the picture right there of the goggles themselves, so you can get an idea of what you're going to be wearing. It won't be often, but it will be needed. And, wear the goggles when I instruct. You don't need to wear them all the time, only when you're firing the Nerf gun. So if you're not firing the Nerf gun and nobody around you is firing the Nerf gun, then you may take them off. It's actually better to not have the goggles on, just only when you need them. Okay. Rotation. So in our studies, there would be things such as fan blades and spinning objects. We're going to use this thing up here called a rotational motion demonstrator. And as you might expect with anything moving, especially in rotation, is to keep your fingers, hands away from the moving objects or the blades. You will not touch the fan blades in any way, shape, and form because they do move very, very fast. However, you will, this will start to rotate. It doesn't move very fast, so you will be able to stop it with your hand, but as always, just be careful of it. You can let it slow down and then touch it, so just be aware of that. So this thing is incredibly heavy. You'll see it when you use it in lab. It's like strangely heavy. So again, be aware and be careful when using this. We're going to put this on a support clamp and make sure that clamp is tight. Make sure that it's completely there and it's secure. If that thing falls, that's going to hurt. So, and damage my equipment. That's the other thing too. I mean, of course, your safety is very important, but I want to be able to use the equipment for next year. So please, please, please be careful with this as well. So fast objects can cause injury, as you might imagine. This is another motion object, so just be aware of it. We're also going to have a case where we're going to take objects and roll them down an incline, and we're going to be measuring things like energy, momentum, potential energy, etc. like that. So again, these are objects that are rolling, that are falling, so you just have to be aware. Springs. Another motion. A specific motion, of course. As you notice, this is one of the labs that we're going to be doing. So these springs are a little sharp at the ends. You can't see it in the photo, but take my word for it, when you have a metal and you coil it up, it's going to have a sharp end. Because of that, you're going to wear goggles. Story about a previous physics teacher of mine. My physics teacher had a student who was using one of those springs, pulled it more than they should have. So this was, of course, what we're not going to do, but they pulled it more than it should have. It shot off the hook and into their eye. So you can kind of imagine that. Now, luckily, the student didn't lose their vision, but they did substantially damage their eye. Because of that, we're going to use goggles. So goggles must be worn at all times when using springs. And because of that, just be aware of the ends. They're not like razor sharp, but as you might imagine, it is sharp. So if you caught on guard, you might scratch yourself. So just be aware of the ends here. Obviously, when the thing is stretched, be careful of your fingers so it doesn't, you don't pinch your fingers. You shouldn't put your fingers near the, as it's oscillating anyway. Don't pull it too hard, because you will launch the spring just as I described, and that can, of course, cause injury to anybody around you. So please use the equipment as intended. So you'll have to pull it down, don't worry, but don't pull it down more than I tell you. You'll be fine. Same thing with Slinkies. We're going to use super Slinkies, which are just really, really, really large Slinkies. Same things apply because it's the same type of mechanism. I'm going to have you stretch that Slinky very, very far. It's going to be very wide. But don't let go of it because it will contract too fast and it could whip backwards. So I'll teach you how to do all of these things as the lab comes. But again, just be careful when using this. Don't overstretch it. That implies with the springs. Don't overcompress it. Don't launch these springs. That's also very important as well. So the big key thing is wearing goggles during these labs and using the lab equipment as intended. That's going to be the very key to being safe during the spring labs. We're going to do a huge unit on electrical work. It's a lot of fun, actually. You're going to all become electrical engineers. I'm going to, of course, teach you how to do all of this. So I broke it down to two parts because you're going to use you're going to use this thing called a power supply. It's pretty easy to use, actually. It's a big adjustable battery. That's all it is. It takes, instead of, your battery voltage of 1.5, I can go up to 20 volts, which is necessary for some labs. With that, there's some safety precautions that you must be aware of. First of all, please use the voltage as I intend. So too much voltage can not only cause electrical shock, it could also damage my components. So we're going to be using these things called resistors and LEDs in our circuit labs. And if you put too much voltage into it, although it may not damage you, it might damage my equipment, which of course is not favorable. I know that accidents can happen, so I get that. I completely understand. One time someone was just using one of my resistors and it just broke. And that was just using it as intended. So I understand that these things happen, but obviously don't do anything that you're not supposed to do in terms of adding too much voltage. So of course that's both for your safety and for my equipment safety. There is safety features in here that actually shuts it off automatically if you put too much voltage in here. In fact, the only thing that you're going to touch in this lab is the voltage knob. This is the current regulator. I will set that before the lab, and that's the safety feature that I told you about. It's automatically going to shut off if there's too much voltage in there. So there's some safeguards in this machine, but I'll always use it as intended. Clearly, I think you know this already, but no wet, please don't come to lab with wet hands for whatever reason, or any water in the lab. Obviously, there's no water in the lab due to our food and drink rule for this reason, but I know that we have bathrooms here that have the hand dryers. Obviously, please use them, but when you come to the room, come back to the room and dry them with your paper towel, just so they're obviously dry. You must use dry hands while using the electrical lab. Always leave this unplugged when you're doing the labs. I'm going to go over all this, by the way, when we get to this section, but it's good to be aware anyway. And just leave it unplugged until I check your circuit. You're going to be building circuits. There's practical and good experiences in doing that. But just leave it unplugged until I check your circuit. I'm pretty good at checking circuits, so I can check it. Well, you know what I mean. I'm pretty quick at also checking circuits. I've been doing this for many years. So I'll check your circuit to make sure that it's okay. And once I give you the go, you can plug it in and turn it on. Make sure that the knob is all the way over to the left here. That's the 0 point right here. I hope you're seeing my mouse. But anyway, make sure it's at 0 before, and then you're going to slowly turn that knob. This is very super sensitive, and you'll notice that when you do the lab. So just turn it very slowly so you don't exceed the voltage that you are using. You'll see that there's an output right here. Make sure those are nice and tight and secure. That's both for your safety and for data collection. And as always, let me know if there's anything unusual or unexpected that happens, and let me check it at all times. So working with circuits themselves, here's a student doing a circuit that she's doing all by herself. She's 100% capable of doing it, and you will be too. I'll give you training and everything. But be aware that batteries themselves can pose damage. Although we're going to be using very small voltages because batteries use small voltages, you do have to be aware of the dangers of using batteries. And I'll go over more detail when we get to it. So obviously if you use a battery improperly, you can have an electrical shock, or you can cause damage to my components. So please use the equipment as intended. That's the big take home from this. We're going to have wires similar to, I know my picture's covering it, I hope you can see it over here. You're going to have wires like this. Don't touch any open or exposed wires. Although we're going to be using very small currents for these types of labs, it's still for your safety not to touch anything until you completely and utterly shut off the power. So shut off the power supply and then change your circuit. And then always ask me to check your circuit if you reattach batteries or whatever you're doing for the lab. Again, for your safety. Once you go through a few of these labs, you'll become more confident and you'll be pretty good at these. But at first, be very, make sure you know what you're doing. And it's very super important that you do the lab as intended. I know that you get really curious during lab and you kind of want to figure out, oh, what happens if I take 3 batteries and make this into the circuit? Or what if I put 4 light bulbs instead of 3 in this circuit? Or what if I take out all the lights in this circuit? You're going to be curious. It's just natural when you do these labs. Big thing, don't do it unless you have my permission, okay? Don't just take the lab and start building your own circuits. Generally, I'll give you permission because I know what the equipment's capable of. I know what their limits are. So yes, maybe you could put the 4th one in. I might even tell you to put the 4th one in, but do not do it on your own. If you do that and I see that in the electrical lab, I remove you from the lab because you're a safety hazard and I don't want you to cause harm to yourself or to anybody else or the equipment. Generally, this doesn't really have a, so those are the major units that we're going to be using. So some of the things is obviously no food and drink at any time. Please don't stand at tables and chairs to reach anything. There are a couple times in lab where you're going to have tall equipment. One of the labs is the flying pigs are literally going to be flying up in the ceilings. Because of that, I'm going to take the pigs up and down. Please do not do that. We will use sharp objects and tools in the course. Scissors, X-Acto knives, wire strippers and cutters. Any sharp tools, please use with caution. You always, when you use the wire strippers, you pull away from you. When you use an X-Acto knife, it's always away from you. And scissors, obviously, just be careful when using them. I know you're all capable and can use scissors and X-Acto knives, but you just have to be aware they can be dangerous if used inappropriately and not carefully. If you ever have a question, let me show you. Also, if anything that's broken that's particularly sharp, like glass or any broken equipment, please let me take care of it. Although you're being really helpful by cleaning it up, I don't want you to cut yourself. I know that's really silly to say it, but it's very true. So if you find that there is broken glass or broken equipment, just have me take a look at it. I'll clean it up. Just stand clear of everything, and that would be a big help for that. So those are your general safety hazards with that. So if there is an incident at all, hopefully there will be none, but if there is an incident, the first and foremost thing you must do is notify me immediately, no matter how small the injury. It could be a paper cut, it could be, I don't know, a bruise. It doesn't matter what it is. I just need to be aware of your safety and your well-being in my course. So please, please, please report, no matter how silly, how small the situation is. I've had students with, who got cut on some lab equipment because it was sharp. I need to know that. If you have a nosebleed, even if it's unrelated to the physics lab, I do need you to please report that. Then what I'm going to do is ask you to basically stand clear of the incident. I'm jumping a little bit, so that I may assess the situation. If it's a minor injury, something that can be treated here and that's easy, I'm going to send you to the nurse. Even if it is a bruise, it doesn't matter. I just want to, 1, be aware, 2, the nurse to be aware of the situation in the lab room. Again, this is all for your safety. Also, if we find that a student is immobile, I'm going to ask you to clear the room and help me by calling the office and the nurse. I've had an instance one time where a student passed out because whatever reason, whatever medical reason it was. So what I don't need is everyone standing there gaping at the student. I need to give that student space. I might need that space in the room. If I do ask you to do that, I'm going to ask you to stand outside the room silently, and then I probably will ask 1 or 2 of you to do some things like call the nurse, get this person over here while I tend to the student. I may ask for your assistance, so please help me. But everybody else, please stand clear of the room if I have a mobile student, if I need some space. If there's a clear and utter emergency, please call 911. You don't need my permission to do that. I'd rather you do that than question it, because if it's an emergency, every second counts. So same thing though, if it's a clear emergency, and I think all of us will be aware of a clear emergency, please clear the room, call the office, the nurse, call 911, whatever we need to do. The important thing is let me handle it. Don't trust, unless I ask you for help, please don't touch the student. Please don't stand around and look at the student. Don't say, oh my gosh, don't take out your phones and take pictures. I don't need that during an emergency. We'll handle it and we'll deal with the situation. In the unlikely event that there's something happening to me, please follow the same procedures that a teacher would. Please go next door and grab another teacher, call the nurse, call the office, and if it's an emergency, call 911. So that's when I'll need your help. I will email the parent or guardian if there is an issue in the class, even as silly as a paperclip. I'm sorry, paperclip. That's too silly, right? Silly as a paper cut. Again, I'm doing this so that the parent is aware that I was aware of the situation, that you didn't get injured and come home and your parents, you come home and like, oh, I got hit by a Nerf gun in lab, and then they're like, oh, how did Mr. Granucci not know? So first of all, it's very important that you report that, and second of all, I just want your parents to be aware. You're not in trouble. I just want them to know what's going on in the class at all times. I think it's absolutely fair for that. Okay, so this concludes part 2, which is what hazards are in physics lab. Part 3 will include where all the lab safety issues, all the lab safety is in the room, and our exit procedures.